Algebra 2, 2-8. Graphing linear and absolute value inequalities. Yes, inequalities. We get to graph inequalities? That sounds awesome. Graphing linear and absolute value inequalities. Huzzah. Okay, we're just going to do a few examples. Here's an example. Graph. X minus 4y is greater than 2. All right, so we're going to graph this. Now, you can graph this right now and do the x or y intercepts if you want to. I prefer to change it to slope-intercept form, and you'll see why in just a moment. But I highly suggest and recommend that you change this to slope-intercept form, which means I've got to subtract x from each side. Oops, we got to subtract x from each side. So I've got negative 4y is greater than negative x plus 2. And then I'm going to divide both sides by negative 4, negative 4, negative 4. And when I divide by a negative or multiply by a negative, I need to switch my sign. So y is less than now positive 1/4 x minus 2 divided by 4, which is 1/2. Okay, so there is my that's what I'm going to use to graph. There's my y equals mx plus b form here. And so I'm going to make some marks on my graph. Here's my coordinate plane. Okay, negative 1/2. When x is 0, y is negative 1/2. So that means I have a point right there. Now, I need to look at my slope, which is 1/4. So if I go up 1 and to the right 4, that's my slope. So I go up 1, to the right 4, 1, 2, 3, 4. There's a point. And then I can also go down 1 to the left 4, down 1 to the left, 1, 2, 3, 4. There's my other point. Now I have 3 points. I can graph this thing. And so now, before I draw a line between these, I need to pay attention to my sign, and this inequality sign here says it's not less than or equal to, only it's less than, not less than or equal to. So if it is not or equal to, then that means this line is not included in the solution set. So I need to do a dotted line here, and that tells me that this line is not included in these y values. Now, y is less than this equation. I need to decide which I need to shade. I need to say which values are included. So here's one thing I can do. I can plug in a value. So how about I plug in a value? Let's plug in 0, 0. I just choose a point. So maybe make a little note here. Shading, pick a point. All right, so I pick a point. So I'm going to pick 0, 0. So I'm just going to plug 0, 0 in here. If it makes sense, then I shade on that side. If it doesn't make sense, then I shade on the other side. So 0 is greater than, or is it, or less than, 1/4, 0, times 0, minus 1/2. Okay, those go away. 0 times 1/4. Gosh, I said that all the way wrong, but I wrote it right. Okay, 0 times 1/4 is 0. So 0 is less than, or is it, negative 1/2. So is 0 less than negative 1/2? No, it is not. That doesn't make sense. So that means I'm not going to shade up here because 0, 0 didn't make sense. I'm going to shade down here. Now also notice this says y is less than this function. Here's this function, and I shaded underneath y is less than. Interesting. Let's do another example. Let's do a u-try. 3x plus 1/2 y is less than 2. Okay, solve for y, get it in slope-intercept form, and then graph this thing. Pause and get to work. All right, let's see how you did. I'm going to subtract 3x from both sides. So I've got 1/2 y is less than negative 3x plus 2. Now I'm going to multiply both sides by 2. I'm going to multiply everything by 2. This gets multiplied by 2, and all of this gets multiplied by 2. So that the y can be by itself. I just want 1y. It's greater than. Now I don't need to flip my sign because I didn't multiply or divide by a negative. I subtracted something, that's totally different. If I multiply or divide by a negative, then I got to flip my sign. But I didn't do that here, so I don't need to worry about it. 1/2 of 2 is 1, so I've got 1y is less than 2 times negative 3x, which is negative 6x. 2 times 2 is 4. Now I can graph this thing. When x is 0, y is 4. 1, 2, 3, 4. There I am. Now if you want to make a t-table to choose, to pick some points here, go ahead and feel free to do so. When x is 0, y is 4, put on some other numbers and plot this thing. I am going to use my slope, negative 6 over 1. So I'm going to go down 6 and to the right 1. 1, 2, 3, 4, 5, 6 to the right 1. 1, 2, 3, 4, 5, 6 to the right 1. And that is a skeleton of my line. This, again, I need to check. This is not or equals to, just like the last one. So that means my line is going to be dotted because this line is not included in my set of solutions. Now I can pick a point and see if it makes sense. Or I can say y is less than, and so I know that I shade over here. When it's this kind of a vertical line, it's so vertical, sometimes it can be hard to decide which one is which. So if I plug in 0, 0, notice how I've shaded in 0, 0? That should work. That should work. So let's plug in 0, 0 and see if it does. We can plug it into the original equation. That sounds fun. 3 times 0 plus 1/2 times 0 is less than 2. 0 plus 0 is 0. So 0 is less than 2. Is that true? Yes, it is. So we shaded the correct way. All right, 2 more examples here. These ones, we're going to look at absolute values. Okay, so let's look at y is greater than or equal to absolute value of x minus 4. All right, let's draw the absolute value of x minus 4. So the absolute value of x looks like this, 45-degree angle through the origin and then back up. So if I were to draw the same thing, 1, 2, 3, 4 down, I've translated down 4. And so then it would look like this. Now I have to decide if this should be dotted or solid. And since this is or equal to, then it is going to be solid. And now I need to decide which side I'm going to shade. I can plug in 0 and see if that works. 0, 0. So absolute value of 0, 0. So I've got negative 4 is less than or equal to 0. Is 0 greater than or equal to negative 4? Yes, it is. So that means the 0, 0 makes sense, and I can shade above it. Or I can say y is greater than my function, so that means I will then shade in above because y is greater. You try one. This is the last one here. Y is less than or equal to 2 times the absolute value of x plus 3. Start with the coordinate plane and go ahead and get to work. Welcome back. Let's draw this one. So I know that my starting point for my parent graph would be, it would look like this for the absolute value. So it would be, the origin would be my starting point, or a good point of reference, I should say. So if I go up 3, that's what this tells me to do. That's my new spot. So go down, go like that. Okay. Now I've got this bloody 2 right here. What am I supposed to do with that? Now remember, the 2 makes it steeper. If it was 1/2, it would make it flatter. But since the 2's there, is going to make it steeper. And how much steeper? It's going to be 2 over 1, up 2 to the right 1. So if I start here and I go up 2 to the right 1, I got a point. Up 2 to the right 1, I got a point. Up 2 to the right 1, there's a point. Up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. And now, do I do a solid line or a dotted line here? It's or equals to, so I do a solid line. There it is. And if I'm not sure with this, I could just plug in points. Get a bunch of points and then connect the dots. Now, y is less than, so that means I'm going to shade underneath. And that is Algebra 2, 2-8. Do a good job on the homework. Test is coming up.